Okay, so when I plug these numbers into my calculator, and you'll want to make sure that you can do that very carefully, and these numbers are going to be the same, but of course dividing by different numbers. What you're going to get here is approximately 0.03933. Now that's the standard error. Now because we have the standard error, we actually have enough to go back and draw our picture. So we said that the difference between the proportions we're assuming is 0, and if we assume that the difference is 0, then we have to pool our proportions, which means that we're going to be using standard error, and we're going to be using the pooled p hat value for each of these, which means that our standard error is 0.039. Okay? Now continuing, what this means is that we can go ahead and finish our picture. So if we go back to the original problem, if this little thing is going to be referring to p hat, so this is going to be PO minus PY hat, which is going to be, we could say that this, if we're labeling our graph here, this is the difference in snoring proportions of old and young adults. Okay, so I could say that that's my label. So we have something that we observed. We actually observed a difference, if you guys remember. So the way that I could find, this is going to be called my P hat of O minus P hat of Y. And what I observed, and this is just based exactly on what they give me in this question, is that P hat O is 39% and P hat Y is 26%. So this is just going to be 39 minus 26, which is, if I do that very quickly in my calculator, and you should also be practicing the same, is 13%, which is what they asked me about in the problem anyway. So 13% is going to be the difference that I find based on the sample that I did. So I'm going to go ahead and put that on my graph. Okay, now this is a two-tailed test, which means that I want to see if it's greater than this amount or if it's less than, okay, and this of course would be negative 13%. And I'm going to have the same area in each tail, right? So now we can go ahead and figure out what that area is. But to do that, we're going to need a z-score, of course. Okay? So to do the z-score, okay, the formula for the z-score is going to be using, and this is something that should make sense to you guys, it's going to be the mean, of course, x minus the mean over the standard deviation. For our problem, I'm just going to interpret what that means. That means we're going to use our sampling difference in proportions minus my mean difference in proportions, which is PO minus PY, over the standard error that they give us, okay? So in terms of what numbers we're actually talking about here, now I'm going to actually go through that. So that would, in this problem, that would mean I would use the 13% minus 0, which is assuming that the populations are the same, divided by the standard error that we found. Okay? Hopefully that makes sense because that kind of lines up with what we've learned before. So your z-score, once you plug in all of those, you have 0.13 divided by 0.039, which means I'm going to have a z-score of 3.3 repeating. Now remember, that z-score would be for the positive one. I could also do the negative one, and that would also make sense in this problem. Okay? Now I'm just going to go through and do to find the p-value. Okay? So this is going to be the p of, and I could say here if I wanted to, what's the probability that the PO minus PY is greater than 0.13 is equal to the probability that my z-score is greater than 3.33. is equal to, and again, I'm just going to do normal CDF to find the areas that are in these two tails. I'm going to have 3.33 to 99. You're going to go ahead and go into your calculator to figure out what that would be if you go to second distribution and then down to 2. I'm just going to do 3.33, 99, paste. Okay, I get a very, very small number. In fact, it's written in standard in scientific notation, but basically what it is it's 0.0004. Okay, now because this is a two-tailed test, my p-value is actually going to be if I multiplied that by 2. So remember, this area is 0.0004, so it's a very small number, but that means that also this area is 0.004. So my p-value is going to be 2 times 0.004, which is 0.000008, okay? And that number we're going to use to write our conclusion. So we're almost done with this whole thing. So that number is, again, we're going to be comparing that to, like we normally would, a significance level. And that's going to help us make a conclusion about our entire thing. So lots of work in the mechanics section on this. Okay, so the very last step is to do the conclusion. Okay, so of course I'm going to start off my conclusion like I normally would. And all good conclusions we could say, using a two-tailed, two-proportion z-test, the p-value 0.0008 is less than my significance or alpha level, which is alpha, of 0.05. I reject the null hypothesis. Okay, so now we're going to state in words what that means. So I'm going to just say there is evidence to conclude, or there is evidence that, and I'm going to go back to my original alternative hypothesis, that the true population, so again, I'm literally just taking whatever I had originally in my alternative hypothesis, so I'm just going to show you guys what that was. That's this sentence right here, I'm just copying it. So I have evidence that the true population difference in proportions of snoring adults under 30 and over 30, I could also say in the older group, is different than 0. Okay, now we're going to break that down into what the problem was originally asking us to make a final statement. Okay, so the original question was asking us, if we go back to it, it said, is the difference of 13% real or due only to natural fluctuations? Okay, well, I'm saying that it is real, right? Because I'm saying there is evidence that it's different than 0, that there is a difference between these two proportions, okay? So I could say there is evidence that and let's just go back to it, the difference of 13% is real, okay? And what does it mean for that 13% to be real. And in particular, it was for are observed is real okay, so there's evidence that it's real and that, let's bring it back to how they worded it, older adults are more likely to snore. Now, this last part that I put in parentheses, I don't necessarily have to say, but it's good for us to actually understand what does it mean to have a positive difference of 13%? Well, if I'm doing PO minus PY, what that means is that there's more older people that snore than younger people. So there is evidence that the difference of 13% is real and that older adults are more likely to snore. This was just to make sure that I understood the context, okay? So I know that these questions have a lot of work done to them between the conclusion and everything that we just did. And if you have any questions, I'm going to be available to answer them during class. Thanks so much, guys. Bye-bye.